Hello and welcome to this presentation on G-code programming for milling operations. In this session, I'll walk you through the complete process of preparing, writing, and understanding G-code for a simple machining project. We will cover everything from machine setup, tool selection, setting the 0 point, cutting a hole, completing the outer contour, and finally reviewing the program structure. By the end of this presentation, you'll understand how absolute programming works, how tool paths are created, and how a CNC machine interprets each line of G-code. What this project is about. This project focuses on machining a simple block with one circular hole and an outer rectangular contour. The material size is 130 mm by 100 mm. With a thickness of 10 mm. We will write the G-code in absolute mode, also known as G90. In absolute mode, all X and Y positions refer to one specific reference point, which we call the workpiece 0. The purpose of this lesson is not only to create the correct code, but also to help you understand how and why each command is used during machining. Machine setup. To begin, we start with setting up the CNC machine. First, the workpiece is placed securely in a vise or clamped to the machine bed. It's important to make sure the block is stable and does not move during cutting. Next, we select the cutting tool, in this case, a 5 mm flat end mill. This tool will be used for both the circular hole and the outer rectangular contour. Before starting any machining, the spindle should be raised to a safe height, typically around Z5 or Z10, to avoid accidental collision. Setting the 0 point. Once the tool and workpiece are ready, the next step is to set the coordinate system. We assign the 0 point using the G54 work offset. This means we tell the machine, this point is X0, Y0, Z0. For this project, the 0 point is located at the bottom left corner of the workpiece, on the top surface. Using a touch probe or manual jog, we carefully touch off the X and Y edges, then touch off the top surface for Z. Once the 0 point is set, every coordinate in our G-code will be based on this reference. Preparing the tool path concepts. Before writing any code, it's useful to visualize how the tool will move. The cutting process has two major tool paths. The first is the circular hole at point O, and the second is the outer rectangular contour. Because the material is 10 mm thick, we will cut in multiple depth passes rather than cutting the full depth all at once. This prevents tool breakage, reduces heat, and improves dimensional accuracy. Hole machining overview. Let's first focus on the hole. The hole has a diameter of 10 mm, which means it has a radius of 5 mm. We move the tool to the center of the hole using a G00 rapid movement. After reaching the hole center, we switch to a controlled feed using G01 and slowly lower the tool into the material. Then, we use a circular interpolation command, either G024 clockwise or G034 counterclockwise, to cut the hole. Because we cut in layers, we will repeat this circular motion several times until we reach the final depth of -10 mm. Helical interpolation. In this project, we simulate helical interpolation by lowering the tool a few millimeters at a time and repeating the circular path. For example, we might cut the hole at Z2, then Z4, Z6, Z8, and finally Z10. Using multiple layers keeps the tool safe and ensures that the hole is smooth and accurate. Circular interpolation is a common method because it allows any size hole to be cut without the need for a drill bit of the exact diameter. Cutting the rectangle. Once the hole is complete, we move on to the outer rectangular shape. This rectangle is 130 mm long and 100 mm wide. We begin the cut at the bottom left corner, which is the same as our 0 point. Using G01 linear movements, we trace the outline of the rectangle. Just like the hole, we cut the contour in several passes, typically in depths of 2 mm each. This allows the machine to cut smoothly and reduces stress on the tool. Depth pass strategy. To cut the full thickness of 10 mm safely, we divide the cut into 5 passes. For example, we might cut the rectangle at Z2, Z4, Z6, Z8, and finally Z10. After reaching the full depth, we perform one finishing pass. A finishing pass uses a slower feed rate and light cutting to improve surface finish and dimensional accuracy. This is important because roughing passes can leave small marks or slight discrepancies. Understanding the G-code structure. Now let's look at how the program is structured. Every G-code program begins with a safety header. Commands such as G21 set the units to millimeters, G90 sets absolute programming mode, and G17 selects the XY plane. We also use G40, G49, and G80 to cancel tool compensation, tool length offsets, and canned cycles, ensuring the machine starts in a safe and predictable state. After this, the program moves the tool to a safe height and begins machining the hole and rectangle. Hole cutting G-code. The next block of code focuses on the circular hole. We wrap it to the hole center, then slowly plunge downward. The circular motion with G03 uses I and J values, which represent the center of the circle relative to the starting point. Repeating this at each depth step produces a smooth, accurate cut. After finishing the hole, we retract the tool back to a safe height. Profile cutting G-code. The contour section follows a similar pattern. We approach the starting point, lower the tool, and trace the rectangle. Each side of the rectangle is cut using G01. The machine moves in a straight line between each pair of coordinates. Cutting in layers ensures that the tool removes only a small amount of material at a time. Once all depth passes are complete, the finishing pass is applied. Ending the program. The last part of the G-code includes a move back to the home position or a known safe point. After that, we include the M30 command, which stops the program and rewinds it. This is standard for most CNC programs and ensures that the machine is ready for the next operation. Safety considerations. It is important to emphasize safety while working with CNC machines. Always check that the tool is tight and the workpiece is clamped firmly. Do not place your hands near the moving tool or spindle. Make sure to run a simulation of the G-code before executing it on the machine. A simulation can reveal potential collisions or errors in your tool path. Finally, stay alert during the machining process and be ready to stop the machine if anything unusual happens. Conclusion. To summarize, this project demonstrates the complete workflow of preparing and running a CNC milling operation using G-code. We learned how to set the 0 point, how to visualize tool paths, how to cut a hole using circular interpolation, and how to machine an outer rectangular contour in multiple passes. We also analyzed the structure of the G-code, including safety commands, machining blocks, and the program ending. By mastering these fundamental concepts, you gain the essential skills needed to write basic CNC programs and understand how the machine interprets every movement. Thank you for watching this presentation. Generated G-code output as per shown. Thank you for your time.